Hypothesis analysis. In my hypothesis for heart rate, I stated heart rate will increase pre-exercise due to the anticipatory rise. This was proven in the results as the average heart rate was 95.7 before exercise, which shows there was definitely an anticipatory rise as the average resting heart rate for a 17-year-old is 75 beats per minute, according to healthy.io. Furthermore, I stated heart rate should increase initially during exercise before it plateaus around 3 minutes until 20 minutes. In our results, the average increase in heart rate was between 0 to 3 minutes was 60%, but after 3 minutes the increase was 2.5% and 5% respectively, showing a plateau in heart rate. The final part of my hypothesis for heart rate was post-exercise, heart rate will return to normal quickly as there are no waste products that need to be removed. Between 20 minutes and 21 minutes, 1 minute post-exercise, there was a decrease in 13%, proving my hypothesis correct. My hypothesis regarding oxygen saturation stated pre-exercise the blood saturation monitor will be around 98% before decreasing during exercise as oxygen is consumed. Pre-exercise, the average oxygen saturation was 99, which is around 98. The reason it was this high is that no oxygen had been used up yet in the aerobic respiration and no carbon dioxide concentration increase has occurred. The average oxygen concentration between 17 and 20 minutes was 89.5, showing a decrease over the course of exercise. However, this did include an anomalous result in Evelyn's test, where she recorded oxygen consumption of 67 at minute 18. If this result is excluded, the average oxygen consumption is 97, which is still a decrease. My respiratory hypothesis stated breathing rate will increase initially during exercise before it plateaus after around 3 minutes as intensity stays the same. This level will remain for the remainder of exercise before it returns to normal quickly post-exercise as there are no waste products to flush out. Initially, between 0 to 4 minutes, the average increase was 47.5%. However, between 12 to 16 minutes, later on in exercise, the increase was a mere 4%. Showing clearly a plateau after around 3 minutes, proving my hypothesis to be correct. However, the only reading that was taken afterwards in Evelyn's test showed an increase in breathing rate from 22 after 20 minutes to 28 2 minutes post-exercise. One reason for this may be Evelyn had an oxygen debt or excess post-oxygen consumption, also known as EPOC. If this was the case, it would mean Evelyn was respiring anaerobically for parts of the experiment. My energy system hypothesis states aerobic glycolysis will be used during steady-state exercise, which means no lactate will be produced during the exercise. Average lactate levels between 0 and 3 minutes into exercise was 14. In order for my hypothesis to be proven correct, the average value would have to be the same at the end of the experiment. In fact, at the end of the experiment, average lactate levels were 7, showing a decrease. One reason for this decrease may be that as the clients were respiring aerobically, which requires oxygen, the lactic acid was replaced by oxygen and carbon dioxide, a waste product of aerobic respiration.